Assalamu alaikum. Dear students, we are starting with the lesson 3, equilibrium. From lesson 3, only two questions are coming. Question number 13 and question number 14. See, question number 13 is connected with center of mass, and question number 14 is connected with the equilibrium, static equilibrium. Okay. First, let us go to discuss the concept in detail, and then we'll do questions related with that. Okay. Now, first let me address center of mass. I think you are aware of center of mass. What is center of mass? Center of mass is a point where the entire mass of the body has been concentrated. Okay. So any object you have, they will be having a particular point where you can balance that object. Okay. But always don't think in such a way that like center of mass will be inside the body. So for example, look at here we have certain case or shape where the center of mass is exactly at the center of the object. See, for the circular disk is exactly at the center, and for a ring it is at the center, but the problem, like, it is not inside the body, it is outside the body. Okay, like inside, like the center of mass is not somewhere over here, it is exactly the empty space. Okay, and third one is exactly at the center, and fourth one is also exactly at the center. So center of mass, you need to keep remember that center of mass can be inside the object as well as it can be outside the object based on the shape of and mass distribution of the object. Okay. Now let us go to address certain questions in connection with that. Before going ahead with the question, like, let me explain two things. See, we know that human body will have a center of mass at the center. Okay, so when an object is jumping or like throwing somewhere, so the center of mass will be executing an arcular or arc or a parabolic path. Okay, so the center of mass, even look at in this particular situation, this is a wrench which is throwing. So that wrench, when you throw, like the entire body of the wrench will be just like rotating like this, but who will be in a like a parabolic path? The center of mass of that particular wrench will be in a parabolic path. So as you can see over here, even though it is mentioned in straight line, but do remember that when you throw, they will be having an arc path or parabolic path. Okay, that is one another understanding in connection with the center of mass you need to remember. Secondly, look at over here. Suppose if I have an irregular lamina, an irregular cardboard, how do I calculate the center of mass of it, or how do I find the center of mass of it? To find the center of mass of it, I need to make a 3-hole. Okay, then I need to hang a weight with a thread on each hole. So why I need to see, if I draw a line over here, one thing I can quite sure that the center of mass will be at one particular point. It's not the exactly point, somewhere in this particular line we will be having the center of mass. So to confirm the center of mass, what I do, I rotate this object and I'll hang the like this particular hole and do the experiment repeatedly. So let me say it is hanging in this way. Okay, so in the third point when I'm hanging, it is hanging in this way. So where all these 3 points are meeting, there the center of mass will be located. This is for an irregular lamina or irregular object. Okay, now let us look at the question which is given. See, the point of an object that move in the same way that a point particle would move. See, these are the particle which is moving in this direction. It is in the same way who is moving, the center of mass will be moving. So which will be the center of mass is a point where which will move exactly the way the other particles are moving. It's follow. Okay. Now, second one. If an irregular shape wrench is thrown spinning across a room, what path it will be its center of mass follow? Okay. So first one, a complex and a wobbly path. Okay. No. Smooth parabolic path. Yeah, this is what we explained. Like when you throw something, it will be executing a parabolic path, especially like when you look at the center of mass will not be spinning. This object will be spin about the center of mass, but the center of mass will be moving in a straight parabolic path. Okay. Now let us go to the next question. See over here. This question came before. A point where all the weight of an object, what is that point called? Say entire mass of the body concentrated one point. What is that point? It's easy, it's center of mass, right? Now look at, based on the figure or based on the definition of center of mass, width which point of the following the center of mass of the solid metallic sphere? It's a solid metallic sphere. So where the center of mass will be located? Is it D? Is it B or A or A? D, B, C or A? So you know that it's a solid metallic sphere. It will be at the center. Okay. Now, see, this is the next question which I explained in connection with the irregular lamina. How can a center of mass of an irregular shaped flat object be determined experimentally? So what it would be? By measuring its length, width, by balancing it at one point, by suspending from a different point. So you know that, like if an irregular object, we have to suspend it from a different point and draw the vertical lines. Okay, so this will be the way we will calculate the center of mass. Okay, now this is a question connected with the center of mass and stability. Okay, I would recall, or I will like connect the stability and the center of mass relation. Stability is connected with the center of mass. How far away the center of mass from the ground? If the center of mass is far away from the ground, it is less stable. If center of mass is closer, then it will be stable. So over here, let me just draw the center of mass of each object. A will be having center, B also will be, C and D also will have center. So look at where the center of mass will be. C the center of mass will be farther away from the ground, which means it is less stable. So C will be less stable. Okay. Now, like what about B? B is comparatively stable than C. Now what about A and B? Look at A and D. The center of mass is little away from the ground, but still this is more stable. You know why? Because the base length also matter a lot in connection with the stability. If the area of contact or the base length is more, then the stability also will be more. As you compare A and D, the base length of A will be lesser than the base length of what? Base length of the D. So in this situation, I can very well say in such a way that like D will be more stable than A. So when we look at, see the question they are demanding, choose the correct order increasing stability. So which is having less stability? C. Then it will be B, then it will be A, and then it will be D. Okay. So this is how the order will be look like. Now let us go to the next question. This is also in connection with the stability. See the stability and base length, there is a relation. Like for your understanding, let me read the question. This fridge is being like tilted for removal. At which position does the fridge begin to unstable? So when will be stable and when will be unstable? That you need to know. Okay. So the first, you need to draw a vertical line from the center of mass to the ground. Okay. If the base line is passing through the vertical line, then it is stable. Okay, draw a vertical line down. If that passes through the like baseline, then it will be stable. Again, you draw the baseline. This is the baseline over here. You draw the vertical line. Still, that vertical line is passes through the base, so it will be stable. Again, stable. Okay. See over here, even this case also it is stable. You draw the baseline and draw the vertical line. The vertical line is passes through what? The baseline. So again, this will be stable. Now, which is unstable? See, when you draw a vertical line, so if it is not passes through the like baseline, obviously it is unstable. So this is the case where we have unstable. Okay, so this will be the answer. Now next, say, how is the mass density of an object such that the center of mass of an object is not located at the geometric center of a body? Understand the question clearly. Think of, I have an object which is, it's a regular object. Okay. Normally, if it is a regular object, we are expecting the center to be at the center of that particular shape. But think of it, if I am making the circle with the two different material. For example, one with the iron and other part is wood. Okay. Do you think this particular object will be, the center of mass will be at the center? Of course not. Why? Because iron is having more mass and wood will have less mass. So where the center of mass will be? Center of mass will be, even though it is a regular object, its center of mass not located at exactly center. It will be some other point. Now, see, the question, why the center of mass is not at the geometric center? So what could be the reason? It will be a non-homogeneous, and it will be constant, it will be large, and it will be small. So which is the correct answer? This is the correct answer. So to make you understand what is homogeneous and non-homogeneous, if you use the same material, if wood or iron, then it will be homogeneous. But if I take a mix of two, then it will be non-homogeneous. Okay. Then next question, the point at which we can imagine all mass of an object to be concentrated. See, next question is connected with the definition of center of mass. I think no need of reading anything, like this will be the definition of what center of mass. Easy. Okay. Now, see, the second question is connected with the static equilibrium. When do we say static equilibrium? To be a static equilibrium, an object must be in two conditions. Which all those conditions? The first condition, it must be in translational equilibrium. It must be in rotational equilibrium. So again, we'll have a confusion when it will be translational equilibrium and when it will be in rotational equilibrium. Okay. So when it will be in translational equilibrium, I'll take an example. Think of it. I have a box. The box is at rest. It's not moving. No doubt about that, it will be a translational equilibrium. This is equilibrium. Okay. Equilibrium. No doubt. In the next case, I have the same box, but now the box is moving at 20 meters per second. Constant velocity or constant speed. Constant velocity. So if it is constant velocity, acceleration will be 0. If acceleration is 0, what is F net? F net also will be 0, which means this is also at equilibrium. Okay. The box is moving with moving. Even though the box is moving, still we call it as it is at equilibrium because the net force is 0. But when it won't be at equilibrium. So if I take the same box, think of a case where the speed of the box is increasing. It's speeding up. Okay, or slowing down. In slowing down and speeding up, the object will be in acceleration. As a result, it will not be in equilibrium. Okay, not an equilibrium. Similarly, when do we say a rotational equilibrium? If an object is not rotating, look at the balance over here, it is not moving, which means the net torque is 0. So it is at rotational equilibrium. Rotational equilibrium. Okay. Now, suppose I am considering a wheel. If the wheel is rotating with a constant angular velocity, constant angular velocity. Okay, constant motion. See, constant angular velocity means alpha will become 0. As a result, torque net will become 0. Okay. So I would very clearly say that if torque net is 0, it will be a rotational equilibrium. So when it will not be at rotational equilibrium? It will not be a rotational equilibrium when the object is speeding up or slowing. Okay. So these are the conditions. Now, when it is at static equilibrium, what is to be noted, when it comes to the calculation part, force in the upward direction must be equal to force in the downward direction. Okay, force up will be equal to force down. This is the key important idea we are dealing with. And what about the next one? See, the next in connection with the torque. So when it comes for the torque clockwise will be equal to torque counterclockwise. Okay, so clockwise torque must be equal to counterclockwise torque. No worries, we'll deal question in connection with that so that you will get an idea. Okay, let us go to the next. See over here, a 1 meter ruler is suspended from a 2 string in a static equilibrium. The tension in each string is 0.5 meter. So we have one force which is acting, FA 0.5 and FB 0.5. Okay, and they are 10 centimeter away from each other. What you need to calculate, what is the weight of the ruler? Don't confuse it with the weight and mass. Okay, mass will be measured in kilogram, weight will be measured in Newton. Okay, so Newton weight will be exactly equal to mg. So we are asked to calculate mg, not mass. Okay, so don't confuse it with. Now, Which concept we will be connecting with? This is a static equilibrium, which means upward force must be equal to downward force. So that's it. Which is upward force? Fa plus Fb. Okay, and which is downward force? Fg. So what it would be? 0.5 plus 0.5, that will be equal to Fg, which means 1 Newton will be equal to Fg. Okay, so which one it would be? This will be the correct answer. Fine. Now let us go to the next one. See, this is another question in connection with the static equilibrium. Here we have two boxes with a mass of 300 and 400 are placed on left of 1 meter ruler. Okay, and keep remember, this is starting from 0. So this is 10 and this is 20. This is 30, 40, at 50 pivot, 60, 70, 80, 90 and 100. Okay, it's 1 meter altogether. Now, right side as shown in the figure. Okay, the ruler is static equilibrium. The ruler is at its static equilibrium. The balance on a pivot at midpoint, use acceleration due to gravity, you can take it as 9.8. Okay. Now, why or what is the question? Calculate the mass of the box C placed on the right of the pivot. So again, it's static equilibrium. You can only use F up will be equal to F down. Okay, and the torque clock will be equal to torque counterclock. Okay, counterclockwise. So again, you will have a concern. Can I use this one? The problem over here, no, because only two forces they have given, no other force. This is also acting down, and this also they have not given. So as long as they are not giving those entire forces, you cannot use this particular equation, F up and F down. Okay. Now we have only another equation which is connected with the torque clock and torque counterclockwise. You know, this is the rotating axis. So A and B will be providing a which torque? Look at, this is a counterclockwise torque. And who will be providing a clockwise torque? C will be providing a clockwise torque. Okay. So what is the idea? Torque of A plus torque of B must be equal to torque of C. Why? Because torque A and B is counterclockwise and torque C is clockwise. So clockwise torque will be equal to counterclockwise. Now again, how do I calculate the torque? We know the equation of torque. Torque will be equal to Fr sine theta. Over here, look at all the masses are acting exactly down and the radius is perpendicular. So sine theta, I will not count. Sine theta will be how much, you know? It will be 90. Okay. So sine 90 will be what? Sine 90 will be 1. So in the equation, I'll ignore which one? Sine theta part I'll be ignoring because it is 1. So when I am writing the equation for the torque, what it would be? It will be Fa into Ra. Okay. And what is Fb? Fb into Rb. Okay. And Fc, I do not know. It's, I'll put okay, Fc into Rc. Now let me put or plug in the values which I have. See, to calculate the force, what I have mass. I'm not converting the gram to kilogram. Even see, here we have given gram and the answer is also in gram. So no need of conversion. Both said we are using the same unit system. So you can do without conversion. Okay. Actually you need to convert that into kilogram, but in this case you don't want. Why? Because like in the option and in the question, the weight, or sorry, the mass is given in kilogram itself. Okay, sorry, gram itself. Now, so what is Fa? How do I calculate? So this is the idea. As they gave the mass, then the force will be calculated by using mg. Okay, so I'll be mentioning mass of the first object into gravitation into radius. Now I need to count the radius. What will be the radius of A? This is the axis of rotation. And this is the distance from axis of rotation to the first object. How much it is? It is 50 and it is starting at 10. So the radius will be 50 minus 10 will become 40. Okay, so 40. So I'll be using 40. Even this also you don't want to convert because all the values we are considering it in centimeter itself. Okay. Now what about RB? Sorry, FB. FB will be equal to MB. MB into RB. What is RB? Again, look at this is standing at 30 and this is standing at 50. So this distance will be equal to 50 minus 30 will be equal to 20. Okay. So this will be 20. And FC, the mass I don't know. I'll be putting it as X. Okay. Into G into RC is how much? Like it's 90 and it's 50. So 90 minus 50, how much it will be? 90 minus 50 will be equal to 40. So I'll be multiplying it as 40. Now G and G, oh, sorry, over here I forgot to put G. Okay, G and G will be getting cancelled because everywhere we have G, so you can cancel it. Now what is MA? MA will be equal to 300 and 40 plus MB is 400. 20 will be equal to X into 40. So rearrange them, you will get the correct answer. So X will be approximately, you'll get just 500 gram. Okay. So which one will be? So this will be the correct answer. Okay. Now let us go to the next question. See, this is also a question connected with the same concept. See, actually, like calculation question, they are not asking. Okay. I think like we can do it later. It will take time. See, their state condition for an object in static equilibrium, but the problem, see, they gave a practice question 41, and that's what practice question is this. Okay. Now, anyway, let me do it. See over here, 85 kg driver walk to the end of the diving board. So he is the one who is walking from here to here and reached. Okay. The board, which is 3.5 meter long with a mass of 14 kg. The board itself is having a 14 kg. It's supported at the center of the mass of the board and at one end. What is the magnitude of force? See, over here you need to find out the force which is acting. So where the force is acting, this force is acting exactly upward. And they have given like the force exerted by the board, and they have given the force exerted by the person. Force exerted by the person, they gave it as 850, and force exerted by the board, they have given it as 140. Okay. So again the concern, can we use F up that is equal to F down? Again no, because they haven't specified anything about like a translational equilibrium. But one thing is quite clear, this is not rotating. So if it is not rotating, what can be done? You can just consider in such a way that torque clock will be equal to torque counter clock. Okay, counter clock. Now again, how do you understand which is clock and which is counter clock? See, they have given this is the axis of rotation. I'll use another color. See, look at F. F is upward. If I draw a circle like this, see, look at this is counterclockwise. So I have one force which is counterclockwise. I'll mention it as TF. Okay, TF is counterclockwise. Torque exerted by the force will be counterclockwise. Now what about the other two? See, other two is exactly, look at, this is acting down. So it will be providing a clockwise torque, and even this also will be acting at the same way. Okay, this is also a clockwise. So torque exerted by the person and torque exerted by the board, both of them are clockwise. So what is the idea? Torque clockwise will be equal to torque counterclockwise. Torque of the person plus torque of the board will be equal to torque of the force exerted. Okay, so that is the idea. Now let us write again. We are using the same equation, F that is equal to, sorry, torque that is equal to Fr sine theta. Here also sine theta part I am ignoring because it is sine 90, it will become 1. So I will be mentioning only F and R. Okay. Now let me mention, see, like the first torque of the person. So how do I calculate torque of the person? F of the person multiplied by radius of the person plus F of the board multiplied by radius of the board. Okay, that will be equal to force into radius of the force, RF. Now again, let me put the value so that you will get an idea. FP is mentioned, how much it is? FP is mentioned 850. Okay, 850, and RP, I know, like, see, this is the axis of rotation, and to the force, how much is the distance? This is 3.5. So I'll be mentioning it's 3.5. Plus FB, what is FB? FB, the board is clearly mentioned, it is 140. And what is the radius? Look at the board force is mentioned exactly at the middle. So you can just count only the half distance of the entire board. So it will be half of it, it will be 1.75. So understand, the total length we will not be counting because only the half distance we need. Okay, so 1.7. And F we do not know, we'll put it as X, and then RF again. See, look at the force is acting exactly at the middle, so this will be at radius will be counted as 1.5. Okay, this is it. Now what is to be done? Now put the value, and you can rearrange, and finally you will get an answer. Like, let me put the values in the calculator. Okay, so 850 multiplied by 3.5 is 2975 plus 140 multiplied by 1.75, it is 245. This will be x into 1.75. Now what is x? X, you can bring this to the other side or shift solve. So how much will be the value of x? It will be 2975 plus 240 divided by 1.75. It's 1840. Okay, that is the force exerted by the board. Okay, now let us look at the next question. A uniform beam is supported at two ends. For a beam to be a static equilibrium, I'll draw the figure. We have a uniform board which is supported at two support. Here one support and here another support. Okay. Now, what is the condition for static equilibrium? So you will say only upward force must be equal to downward force. No, this is which equilibrium? Translational equilibrium. Only clockwise equal to counterclockwise. No, this is also rotational equilibrium. See, both transition and rotation together we call it as which one? Static equilibrium. They are asking for static equilibrium. So both force and torque must be balanced. Okay, so C will be the correct answer. Now the next one. Which of the following condition must be met for an object to be in state of complete static equilibrium? It's same like the previous question. Okay, this is wrong because net force is zero, not only needed. Like torque is zero, not only needed. Both net torque and force must be equal to zero. That's it. Okay, now when next external force acting on a rigid body is zero, okay, rigid body is zero. What does it mean? It is translational equilibrium. Okay, translational equilibrium. Okay, is the rotational equilibrium is in rotational equilibrium? Wrong. Is in translational equilibrium, has a zero linear acceleration. Yes, translational equilibrium acceleration must be zero. Okay, so which one it would be? B will be the correct answer. Definite. Now, state a condition for an object to be in a static equilibrium. Okay, state a condition for an object to be in static equilibrium. I think it's easy. Yeah, sorry for that. State, this is the learning objective 14th. Okay, why is a vehicle with a body rise up less stable? This is what we have done one question. Like if the center of mass is above, far away from the ground, then it will be less stable. See, even you can think of it Burj Khalifa. See, their shape is look somewhat like down is broader and up is very less. So the center of mass will be closer to this surface so that it will be more stable. Okay. So it has more stability. It has center of mass is higher and it will rotate faster and its resistance increases. So if it is rise up less stable, its center of mass rise up. That is a reason. Now, where is the center of mass of a roll of masking tape? Masking tape. Center of mass of masking tape. It's not connected with the 14. It is connected with the question number 13. So if it is a masking tape, you know that it will be like a ring like structure, so it will be at center, at the geometric center of the hole. Okay, now how do the surface ocean current move in a earth hemisphere due to earth rotation? See, this particular question I have explained before. Okay, like earth rotation and its direction. So earth will be rotating like counterclockwise in this particular axis, but when you look at on top of the north, you will see it as counterclockwise. But when you look at this particular motion, you will feel it like when you look at on top of the south pole, you will feel it like it will be moving in a clockwise motion. Okay, so this question I have explained before. Just go and check the videos, okay, so that you will get the idea. See, north counterclockwise and south clockwise. So which one it would be? This will be the correct answer, B. Now, these are certain questions which came for the previous chapter. Okay, I have put this together. According to Newton's second law of rotation, an angular acceleration of a rigid body is directly proportional to its moment of inertia, inversely proportional to net torque, and directly proportional to the net torque, and inversely proportional to moment of inertia. Let me write the equation for the Newton's second law in rotation. See, alpha is what? Angular acceleration. This will be equal to torque divided by moment of inertia. See, alpha is directly proportional to torque and inversely proportional to moment of inertia. So which one will be this one? Okay. Now next question. Replacing a solid disc wheel with a hoop style wheel of same mass and radius, which option will be correct? Okay. Understand it clearly. This is also connected with the same concept. Okay. See, I have a solid disc whose mass is m and radius is r, okay, and whose moment of inertia will be mr square divided by 2. I should remember this, okay. And secondly, this I am completely replacing with a ring which is having the same mass and the same radius, okay. So over here the moment of inertia will become mr square. So which is having more inertia? See, hoop is having more inertia than the disc. So, which will be a higher angular acceleration? See, more inertia, less acceleration. So the hoop is having more inertia, it must be having less acceleration. Okay, so which one would be lower angular acceleration for a same torque? Okay, so this is what you need to understand. Here we are changing the object. One is having less moment of inertia, another one is having more moment of inertia, and both the masses are exactly same, so their torque will remain same. Okay, now see, lesson 3 is over, only 2 questions. Now lesson 4. This is lesson 4. Lesson 4, we have around 6 questions. Question 15, 16, 17, 18 and 19, 20. 20th question we will be discussing along with the lesson 5. Okay, so hopefully we will be discussing this 5 questions together. Okay, so first let me explain the concept and then we'll go to the question one by one. Okay, now look at the learning objective. Explain what happened when a player hit a ball in terms of acting force and their effect on a colliding object before, during and after. So when an object is collide or when an object is coming to hit another object, so during collision and after collision and before collision, what will happen? Okay, that is the first concept. See, basically they are connecting with the Newton's third law. Action will be equal to reaction. Okay, and moreover you need to remember the momentum before and momentum after will be equal. Okay, the force when they contact each other, the force of interaction will be same. To make you understand, suppose a ball is hitting on a wall. Okay, I'm throwing a ball on a wall. See, ball is giving 100 Newton force. Do remember that the force exerted by the wall also will be 100 Newton in the opposite direction. Okay, this is what during the interaction will take place, which we call it as Newton's third law. Okay, every action there is equal and opposite reaction. That's connect with which one, like 15, question number 15. Then see, I'm connecting with the question 15 and 18 together. See, this is linear momentum equation. Calculate the momentum of a different system. So let me explain what is momentum. See, momentum is represented with the letter P and it will be calculated by mass times velocity. Okay. See, momentum is connected only with the moving object. If the object is not moving, we don't have momentum. To make you understand, like I have a bicycle and I have a car. Both of them are moving at the same velocity. Velocity is same. Over here it is 10 meters per second. Here also 10 meters per second. Think of it, this both of them come and hit on a wall. Which vehicle will create more damage? Obviously the car will be damaged more, right? Why? Because it is having more momentum. Okay. So the impact created by a moving object, we call it as momentum, that can be calculated by using mass and velocity. Okay, and it will be having an equation P that is equal to mv. Moreover, you know, mass will be calculated, or the SI unit of mass will be kilogram, and velocity is meter per second. So momentum will have a unit of kilogram meter per second. Okay, so this is what we are connecting with the 15 and 18. Especially question number 15 is not much clear about like what they are asking. So they can connect Newton's third law, they can connect change in momentum, they can connect the conservation of momentum, they can connect like impulse, everything they can connect with the 15. Okay, now question number 16, and 17, even like 18, not 18, 19 is connected with the impulse. So in connection with the impulse we have more questions. Okay, define impulse, product of average force and time, interval of which act, derive the impulse expression from Newton's second law of motion and specify its SI unit. Okay, see, I'll make it clear. See, these concepts are very much needed for this particular lesson, especially in connection with the calculation as well as in connection with its SI unit. So first and foremost, understand what is impulse. Impulse will be represented with the letter J. It will be force into delta T. So what is impulse? Force times delta T. What is delta T? Delta T is time. So force will be represented with Newton, and delta T is represented with force. The SI unit of force will be Newton, and time will be second. Okay. Now what is more important over here? You know, so the SI unit of impulse will be Newton second. But over here in this particular learning objective, this mentioned derive the impulse from the second law and specify its unit. I'll connect it. See, what is second law? Anyway, we have a particular slide which is coming. See, I think better I'll be explaining it there. See, remember, one SI unit will be Newton second. We have another SI unit in connection with the Newton's law. Okay, so we will come to that later. Fine. Okay, now let us go to the next one. And moreover, try to understand impulse is a vector quantity, and the impulse will have a direction of velocity. Impulse is a vector quantity, so if it is a vector quantity, it must be having a direction, right? So what is the direction of impulse? Direction of impulse is exactly same direction of velocity. Okay, now the next one, apply impulse momentum theorem to solve the relevant equation. This is what I said. Okay, question number 19 is connected with impulse momentum theorem, and it has been derived from Newton's second law. And in question 16 I said there are something which is connecting, which they are connecting Newton's second law and its SI unit. So how do they connect it with? See, this is what we call it as F is equal to ma. We call it as Newton's second law. Okay, this is Newton's second law. Okay, so what is m? M is mass, and what is a? Acceleration. So how do you calculate acceleration? Acceleration is change in velocity divided by change in time. Okay, so this acceleration we can replace with a delta v by t. You know, like, what if I multiply this with a delta t? This delta t and delta t will get cancelled. I'll be getting f delta t will be equal to m delta v. Okay, f delta t will be equal to m delta v. What is delta v? Delta v is nothing. It's v final minus v initial. Okay, so what is v final? Mv final minus mv initial. Mv, I know it's momentum, so I could write it as pf minus pi. Now, why I am explaining this? This is the impulse momentum theorem. What is impulse momentum theorem? This is what you need to remember. The impulse F delta t always will be equal to Pf minus Pi. What is Pf minus Pi? It is delta P. So impulse will be equal to change in momentum. Impulse will be equal to change in momentum. This is what we call it as impulse momentum theory. Now, I asked you to recall the SI unit of impulse. What is the SI unit? Newton second. But do we have any other unit in connection with the impulse? Yes. See, this equation we derived from the second law. So according to second law and impulse relation, what is the impulse? Impulse is exactly equal to change in momentum, which means what is the unit of momentum? We already know that it is kilogram meter per second. So basically impulse is having two units, one is Newton second, another one is kilogram meter per second. Okay, this both unit can be asked for the exam. See, question number 16 is connected with the unit, so be conscious of it. Okay, now see, there is question number 17. Question number 17 I haven't addressed much. Question number 17 is connected with question number 7 is in connection with the impulse calculation from graph. Impulse calculation from graph. This is question number 19. It's just exact same explanation which we have done before, but I forgot to explain question number 17. Question number 17 is in connection with the impulse calculation from graph. No worry, they will be giving a shape of graph. Okay, let me say this is a shape of graph. There will be having force and time. See here, if you try to calculate force into delta t, don't ever think that you will get the impulse, the same impulse. Okay, it would be wrong. Okay, when we can use this one for a constant force, throughout a constant force if you are applying, we can use this one. Okay, over here the force is not constant. First is increasing, then it is constant, then it is decreasing. If it is non-constant forces, if they are giving graph, you will calculate the area of graph to get impulse. Okay, so when it's a graph question, do remember it's area of the graph, nothing else. Okay, now let us go to the questions in connection with this chapter. First question, look at a cart move at a constant speed. Its linear momentum is 12 kg meter per second. So initially it is moving with a speed and it is having a momentum pi is how much? 12 kilogram meter per second. Okay, then if the weight are added to the cart such that its mass doubled while its velocity remain constant. Okay, previously it is having a velocity v and now the velocity is also v, but previously it was having a mass m, but now the mass they doubled to m. So what is the momentum in the first case? Pi. I can very well say it will be m into v. What is the value they have given? They given it as 12 kg meter per second. Okay, now what about the second p2 in the final? In the final or p2 case, in the second case I'll say p2. Okay, that's better. So mass is 2m and velocity is v. Look at m into v is what? M into v is 12 kg. So you can write the value in such a way that 2 into 12 kilogram meter per second. So together it will be 24. 2 into 12 is how much? 24. So which will be the correct answer? This will be the correct answer. Okay. Now let us go to the next question. A particle mass is m, move with the speed v. Okay, so particle 1, let me again mention, particle 1 is having mass m and it's move with the velocity of v. So what is the momentum of the first object? mv. Okay, second one, another particle. Okay, we have bigger object which is 2m mass and move with the velocity of 0.5 v. Okay, so what is p2? P2 will be equal to 2m into 0.5 v. Now what they want? What is the ratio of the momentum of first particle to the ratio of the second particle? So you need to find the ratio of P1 by P2. So what is P1 by P2? I think it's easy. It will be mv, P1 is mv, denominator, what we have? We have 2m into 0.5 v. Okay, m and m we can cancel, v and v cancel. So numerator you have 1 and 2 into 0.5 is also 1. 1 is to 1. So which one will be 1 divided by 1? Okay, this will be the correct answer. Now the next one. A 1 kg ball has a velocity. Okay, we have a ball which is 1 kg and having a velocity 12 meter per second. Okay, downward. Okay, it's in downward. So downward velocity we normally will take it as minus 12 meter per second. Okay, strike ground, bounce up with the same velocity. See, it is hitting on the ground and then it is rebounding with the same velocity. So it is 12 meter per second. Okay, what is the change in momentum? I think it's easy. Change in momentum, how do you calculate change in momentum? First you will calculate pi and then you will calculate pf. Or see over here, they haven't mentioned the momentum and final momentum initial and momentum final. See, to calculate the change in momentum delta p, we can use an equation. It's m into v final minus m into v initial. So same way, if you m you take it as common, it will be v final minus v initial. Okay, so you can use this equation. M v final, m is what? 1. Okay, so what is v final? V final is 12. Okay, what is v initial? Minus 12. So minus and minus together it will be plus and it will be 24. Okay, 24, and over here change in momentum we are getting positive, which means it will be upward. Okay, so which one will be upward? E will be the correct answer. Now let us go to the next situation. In which of the following case does the ball experience the greater change in momentum? Okay, so we have three cases. A ball moving to a right at a speed of v and brought to rest. So initial velocity is v and final velocity over here is 0. Okay, and second case, the same ball, the mass is same, initially at rest, so vi is 0, is projected at a speed of v toward the left. So you are throwing it in the left side, so vf is what? Vf is minus v. Okay, third one, the same ball, mass is same, again moves to the left with the velocity, so vi is minus v. And what is vf? Vf is minus 2v. Okay, speed up, so minus 2v. Okay, now what will be the value of change in momentum in each case? Which one is having greater change in momentum? So let us calculate. Delta p is equal to m into v minus vf minus vi. Okay, so in the first case it will be m into v final is 0 and v initial is minus v. Yeah, just v. So finally I'll be getting minus mv. Okay, first case is minus mv. Now this is the first calculation. For the second calculation, again delta p will be equal to m v final minus v initial. Okay, this will be equal to mass is same for both the previous case and this case, but here the initial velocity is 0 and final velocity is negative. So final velocity is minus v and 0. So again you will be getting minus mv. Okay, now in the third case, delta p is equal to m into vf minus vi. So again over here, look at mass is exactly same. Okay, what is v final? V final is minus 2v, and what is v initial? Minus minus of v. Why there is a 2 negative? Because in the equation we have a negative and the initial velocity is negative. So this will become plus. Okay, so minus 2v plus v, what we will get? We will get m into minus v. So m multiplied by minus v will become m times minus v will become minus mv. So what is noted? Case 1, case 2 and case 3, all the three cases we have exactly the same momentum, change in momentum. So this will be the correct answer. Now let us look at the next one. A ball of mass m is thrown horizontally at a speed of v towards the wall. Okay, it's rebound horizontally with the same speed, neglecting the gravity effect. Magnitude of the change in linear momentum of a ball is. See, again let me look at. See, we have a wall over here and I'm throwing a ball, okay, in this direction. Okay, I can take in another direction as well, there is no problem. See, initially its velocity is v. Okay, as it coming in the left side, I'll take it as negative. Okay, and after hitting it will be rebounding with the same velocity. Okay, and over here it will be positive. So which is v minus v? Vi, which is positive v, it's vf. Okay, they're asking us to calculate delta p. What is delta p? It's m into v final minus v initial. Okay, so m into v final is v minus minus of v. Why there is 2 negative? Because the initial velocity is negative. So it will become plus v will become 2v. So I'll be getting 2mv. So which one will be, when it is rebounding with the same velocity, it will be double the momentum. Okay, it will double the momentum. It's important. Please keep a note of it. Okay, now I think this is a calculation which I don't want to do. It's a repetition actually. A golf ball mass is given, okay, moving initially at Vi is given. Hit a stationary club head of mass 0.2 kg. This is the second mass. To make you confused, after collision, the ball rebound. Okay, rebound means coming in the opposite direction. What is the change in momentum in the ball? Change in momentum in the ball you need to calculate. So how do you do? Again, m into v final minus v initial. So this is the equation. You need to identify which is v final and which is initial. V initial you take it as 14, then V final must be 30, but if this you take positive, this must be negative. Okay, so why? Because it is rebounding. One moves to the right, and after rebounding means it will come to the left. Okay, so that's the reason I have taken it as negative. So V final I am taking it as negative over here. The reason behind that is returning. Okay, returning velocity will be taken as negative. Then like which mass I'm supposed to see, they're asking the momentum change of a ball, so I'll be selecting only the mass of the ball. So it will be 0.045 multiplied by which one? V final, it's minus 30 minus Vi, it's 40. Okay, so minus 30 and minus 40 together it will be minus 70. When you multiply you will be getting minus 3.15. Okay, so you just do that, like negative is not specified in the equation, so that you can very well choose B as the correct option. Okay, now let us look at the next one. A baseball bat hit a ball for a 0.02 second. So what is this? This is the time interval. Okay, second is time interval. Producing an impulse. See, they have given impulse. This is impulse. Okay, what is the average force exerted on the ball? See, they have given impulse, and we know impulse will be calculated F into delta t. See, impulse is given and delta t is also given, so you need to calculate F. I think it's easy. I'll draw the triangle. See, over here it's impulse. Impulse is F into delta t. So what is force? Force is impulse by delta t. Okay. So over here impulse force will be equal to impulse J divided by delta T. So this is 1.6 divided by 0.02. Okay, 0.02. As you divide both of them, you will be getting 80. Okay, 80 Newton. So this will be the correct answer. Now next one. A cricket ball and a bat collide. The bat slowly bat slows slightly after the impact. Okay, after hitting, the bat will be slow. Okay, cricket ball will be faster. Which principle explain this? See, anyway, this concept we will be discussing in detail in last chapter, conservation of momentum. See, this is due to conservation of momentum. Before and after collision, conservation, momentum will remain same. Okay, that is the idea, and we will be addressing it later. Now, this is next questions in connection with the linear and angular momentum and impulse. Okay, we have 240 kilogram of snowmobile, speed up from 6 to 28 in 60 seconds due to a forward force. What is the impulse? See, they're asking impulse. Impulse, we know it will be force into delta t, but we don't have a force over here. Generally, when we see kilogram, you multiply that with the acceleration due to gravity, then that will be substituted as force. No, that is wrong. Over here, they have given another way. They have given mass and final velocity and initial velocity. According to impulse momentum theorem, F into delta t must be equal to delta p. So what is delta p? M into V final minus V initial. Okay. So over here mass is given 240 and see initial velocity is 6 and final velocity is 28. So what will be 28 minus 6? Okay, just do the calculation, you will get the answer. I'm not doing this anymore because it's easy. You'll get an answer. Okay, now let us look at the next one. This I'll do. This one, the calculation you do and find out the correct answer. Okay. Now the next one, a ball with a momentum 25 kilogram meter per second strike a wall perpendicularly and rebound at same speed. This ball is coming and hitting, and it is coming back with the same speed, which means Pi and Pf, the momentum will be exactly same. Okay, if this is 25 kilogram meter per second, this must be minus 25 kilogram meter per second. Why there is a negative? Because it is rebounding. Okay, now what do they want? Okay, opposite direction. The collision last delta t they have given, it's 50 millisecond. So if it is 50 millisecond, how do you convert into second? It will be 50 into 10 to the power minus 3 second. Okay, or you divide with 1000, or you just multiply that with 10 to the power minus 3. Okay, now what we need? We again need average force. What is the relation again? F into delta t must be equal to delta p. Okay, so what is they need F? So what is F? F will be equal to delta p by delta t. So I'll write what is delta p. Delta p is p final minus p initial divided by time is 50 into 10 to the power minus 3. Okay, p final is minus 25, p initial is minus 25 whole divided by 50 into 10 to the power minus 3. See, both will be added together. I'll be getting 50. Okay, 50 minus 50 divided by 50 into 10 to the power minus 3. So you will get an answer 1000 Newton. Okay, so this will be the correct answer. Now, the next question is in connection with this. A 220 kilogram vehicle travel at 26 meter per second. Okay, mass is given, and its travels initial velocity is also given. It can be stopped. Stopped means the final velocity is what? V final must be 0 in 3 different ways. So you can bring that car to stop in 3 different ways. One, by applying gently a brake, it will take 21 seconds, and you can apply a hard brake, it will take 3.8 seconds, or you can hit on a wall and stop, it will take 0.22 seconds. Okay, now again what they're asking, what is the average force exerted on the vehicle when it hits the concrete wall? Okay, so when it hits the concrete wall, what will be the average force which is given? Again, which concept is connecting over here? Okay, they have mass, we have final velocity, and we have initial velocity. Okay, what I can calculate? I can calculate change in momentum. Okay, change in momentum I can easily calculate. Then what is to be asked? They are asking average force. So average force and change in momentum, what is the relation? Delta P will be equal to F into delta P. So do I have delta T over here? Yeah. What is the value? They are hitting on a concrete wall. So for a collision wall will be 0.2. Okay. So F again will be equal to delta P divided by delta T. Okay. Delta P, how much it will be? Delta P will be comes out to be 220 2200 multiplied by in bracket 0 minus 26 it will be. Okay, so I'll be getting a number 2200 into 26, and this will be negative. Okay, so I'll put that value over here. So I'll be getting minus 2200 into 26 whole divided by delta t. What is delta t? Delta t is 0.22. So when I'm cancelling it, finally I'll be getting 2.6 into 10 to the power 5 Newton. Okay, so this will be the answer. Okay, check it. Now, next question. See, which of the following is not the true regarding impulse? Okay, we know that impulse is what? Impulse will be force into delta t. Okay, or it will be delta p, or it will be mass into v final minus v initial. So look at first one. Ma is what? Force. Force into velocity. Force into velocity? No, wrong. Force into delta T? Yes, correct. Mass into V final minus initial? Yeah, this is delta P, change in momentum. Yes. And I, like impulse, will be F into delta T. So this is also correct. So which is wrong? This is wrong. Okay. Now, this is, I think you can do try to calculate it. See, it's a rebounding case. We have done many questions. So the answer will be comes out to be like this one. Check it. Okay. How do you calculate it? I'm not spending time for that. Now this particular question I'm just spending a bit time. Okay. A 7 kg object is moving at a speed of 2 meter per second. If the subject to a force in the direction of its motion. See, we have an object which is moving with a 2 meter per second in this direction, and you are providing the force in the same direction. Okay, you are providing that force for how many? 1 second. Okay, and it's shown force time graph. See, the force time graph is given. Now, as shown in the force time graph, what are the resulting speed and direction of the object after force being applied? See, an object is moving. You are applying a force in the same direction. Of course, its final velocity. This is Vi. Vi is 2 meter. Vf we do not know. Okay, Vf we are supposed to calculate, and which direction we can predict, because we apply the force in same direction. So the direction will be in the original direction. Okay, so we have this and this and this. Okay, 3 of them are in the original direction. Okay, now what is to be noted? Like which concept they are actually testing. See, they have given a force time graph. If force time graph they have given, the area of force time graph will be what? Impulse. So from this relation I can easily calculate the impulse. How do I calculate impulse? Impulse will be exactly equal to area of the graph. What is area? This is a rectangle, I think. Okay, so area of rectangle will be equal to length into breadth. So over here, what is length? Length is 5 and breadth is what? 2 minus 1. Okay, 2 minus 1 is 1. Okay, so what will be the impulse over here? F into delta T, I found it as like 5. Okay, 5 Newton second I got. Now look at what they want actually. They want final velocity. How do I find final velocity? This is the relation you need to remember always. See, impulse will be equal to change in momentum, delta P. Okay, so impulse I calculated that is 5, and change in momentum, how do I calculate? M V final minus M V initial. Okay, so like you can put it in this way as well, like in this way. So mass is given 7, V final we do not know, put it X, and V final it's given 2. Okay, so when you rearrange and shift solve, you will you will be getting 2.7. So which option will be? C will be the correct answer. Okay, 2.71 in the original direction. Okay, now next question. What is the SI unit of impulse? SI unit of impulse, as I mentioned, we have two SI unit. One is Newton second is one SI unit. Another one can be represented with a kilogram meter per second. Okay, so this both have the same unit of what? Newton second and a kilogram meter per second both have the same unit of impulse. Now look at this question. Which of the following is correct unit of impulse? Okay, impulse will be equal to change in momentum. Okay, so change in momentum unit will be exactly equal to the impulse unit as well. Momentum is having kg meter per second, so impulse is also having the same unit. So which one it would be? C will be the correct answer over here. Okay, now this is which is the following is correct unit of the moment of inertia. Moment of inertia, you know that it's mr square. Okay, so m is kilogram, r is meter square. So kilogram meter square, which one it would be? So the first one will be the correct answer. Now, which statement is correct? Newton's second law and impulse. See, Newton's second law and the impulse relation. The impulse is equal to rate of change of momentum. No, impulse is not. Force is equal to rate of change of momentum. So this is wrong. Impulse is equal to change in momentum. Yes, impulse is equal to change in momentum. This is the correct representation. Now, what about the next one? Look at a Newton's second law state that the net force of an object is equal to the rate of change of momentum. Look at force is equal to change in momentum, rate of change of momentum. Okay. Now, which step is correctly derive the impulse momentum relation? So, how do you get the impulse momentum theorem? So, what is to be done? Multiply both sides with v. No. Velocity, if you multiply, you will get some other quantity. That is not correct. Multiply both sides with the time. Of course, when you multiply this with the time, and this also will the time, you will get f into delta t. This is impulse, and it's delta p. Delta p is what is delta p? Delta p is change in momentum. So which one will be? B will be the correct answer. Okay. Now let us go to the next one. See, no need. You know, if we have force and time, what do? We find the area of the graph. Over here, area of the graph is 20 into 5. It will be 100. Okay, 100 Newton second will be the impulse. Okay, area of the graph they are asking over here, that is impulse. Now, this is a good question. Look at a 4 kg block slide along a frictionless surface with a constant speed. So the initial velocity is mentioned, Vi is mentioned how much? 5 meter per second. Okay. 2 seconds after 2 seconds, the horizontal after it begin to slide in a horizontal time dependent force applied on the mass. Now after 2 seconds you are applying a force, a 6 Newton force is applying for another 6 seconds. Okay, and then you are providing a 3 Newton force. Okay, so from the graph you can see. Now the force is removed at 8 seconds later. Okay, the force right after 2 after 10 seconds means after 8 seconds you remove it. Okay, the graph shown how the force on a block has varied with the time. Okay, we have a force time graph. Now, what is the magnitude of the total impulse? You need to calculate the impulse over here. So how do you calculate impulse? You know that as it is a graph, area of graph will be equal to impulse, right? So what is area? See how many shape I can have over here. Look at, I can take this is one rectangle 1, and I can take this another rectangle 2. So what is the area of the graph? Rectangle 1 plus rectangle 2. Okay. So first I will calculate the area of rectangle 1. What is rectangle 1 area? Length into breadth, right? So what is length over here? Length I can mention it as 6. What is breadth? See, look at, it is this much distance. So 8 minus 2. So 8 minus 2 is how much? Again 6. So 6 into 6. What is 6 into 6? 6 into 6 is 36. Okay. This is R1. Similarly, I need to calculate for R2, rectangle 2. So what will be the equation? Again same. Length into breadth. Length is what over here? Length is 3. Okay. So look at the length, height over here, it will be 3. So it is 3. And what is base? See, stopping at 8 and starting at, stopping at 10 and starting at 8. So it's 10 minus 8 will become 2. Okay. So 2. So finally what I'll get? I'll be getting 6. Now, as I mentioned, what will be the total area? Total area will be, you need to add them together. Okay. So what it would be? 36 plus 6, it will be 42. So which will be the correct answer? 42. Okay, this is it. Now, what approximately is the speed of the block after 10 seconds? See, after 10 seconds, what will be the speed? So how do you calculate? The same, impulse F into delta t will be equal to m into Vf minus Vi. Okay, this we calculated where it is 42. Okay, and mass is given, it's 4 kg, and V final we do not know, put x, and V initial we know, that is 5. Okay, so it will be approximately how much, it will be around 15.5, which will become 16. Okay, so which will be the correct answer? 16 will be the correct answer. Okay, now look at, this is another question. For a constant force, impulse is equal to, for a constant force, impulse, how do you calculate? The slope of the graph. No, slope is not the impulse. the area under the graph of, yes, area of the graph will be giving the, which one? Area of the graph will give the impulse. Okay. Now again, this is another equation, sorry, another question. I think a resultant force x act in the x direction. Force is acting in x direction. A stationary box 3 meter per second, 3 kg for a 10 second. A force time graph shown at 3 region. Okay. What is the total impulse? Impulse acting on the box in 10 seconds and in which direction? See, direction is quite easy. The force is giving in which direction? In the forward direction. So it will be positive x direction. Okay. All the options have positive x direction. Now, second one is connected with the like impulse. So how do I calculate impulse? I can do a direct calculation. Direct calculation means it is look like a trapezium. So I can calculate area of a trapezium. Area of trapezium. So what is area of trapezium? You know, area of trapezium will be half into a plus b into h. Okay, so you should know what is a and you should know what is b and what is h. Height, we know this is the height. It's 4. What is a? A is the long distance. Long parallel distance is a. So a over here it will become 10. So what is b? Look at b is small parallel distance. So it is stopping at 6 and starting at 4. So 6 minus 4 is how much? 6 minus 4 is 2. So b will be 2. So you put the value half into 10 plus 2 into 4. So how much you will get? You will get 6 into 4. It will become 24. So 24 is the correct answer. Do we have 24 over here? No. So let me make this as 24. Okay, 24. Now to avoid confusion, see, we can do this in other way as well. Like we can make this particular shape into 3 different. One is a triangle 1, another one is triangle 2, and the third one is a rectangle 1. Okay. So what I do the calculation of area of triangle, rectangle, and then I'll add them together. So first I'll calculate triangle 1. Triangle 1, what is the equation? Half into b into h. Okay. So what is base over here? Base, see, for the triangle base is, look at, this is 4. Okay. So 4 into height is what? Height is also 4 divided by 2. Okay. 2 and 2, and finally I'll be getting 8. Okay. So what about the second triangle, triangle 2? Again, the equation will remain same. Half into b into h equal to, see, look at the base again, it is 10 and 6. So if it is stopping at 10 and starting at 6 means what will be the base? Base 10 minus 6 together it will be 4. So base for the second triangle will be 4. Okay. Now again, what is the height? Height is not changing. Height is exactly 4. So again, this also I'll be getting 8. Okay. Now for the rectangle one, what is rectangle one? For a rectangle one, look at it's L into B. What is length over here? Length, see, the height of this particular. So length, or here I'll take it as 4. And what is base? Base, it is stopping at 6 and starting at 4. So 6 minus 4. 6 minus 4 is 2. So again, this will be 8. Look at. So what is the total area? So area will be equal to triangle, second triangle plus rectangle. It will be 3 into 8, it will be 24. So 24 is the answer. In the option there is no 24. So make this as 24. So B. Now look at the next question. A 7 kg object is moving 2 meter per second. It receives 2 impulses, one after the other. Okay, so we have an object which is moving with the initial velocity vi with 2 meter per second. Okay, and you are giving an impulse or force time in this direction, that is 5 Newton second, and here also you are giving the same impulse in the opposite direction, minus 5 Newton second. So what can be? What is the net impulse? Net impulse over here, F into delta T, the net F naught will be 0. Okay, so change in impulse, like we don't have an impulse over here, both of them will be getting cancelled. Okay, so which mean, so do you think the change in momentum will be there? According to conservation, not conservation, according to impulse momentum theorem, F into delta T is change in momentum. So if this is 0, this must be 0. If Change in momentum is 0. What is the initial and final velocity? It will remain same. V final and V initial will be exactly same. It is 2. And what will be? It will be exactly in the same direction as well. Okay. So which one I can say? So 2 meter per second towards the forward. Okay. Now next. Anyway, this question I am not doing. This is a repeated question you try to do, and even this also we have done before. Okay, like both you do. Now this is the last question which we are dealing today. A block of mass m is sliding. Okay, we have a inclined plane where a mass is sliding. Okay, mass is sliding and it attains a velocity. Now it attains a velocity of v. Okay, and to stop this particular object you are applying a force. Okay, and you apply a force and you took how much? Delta t1 second. So what will be delta p over here? Delta p will be equal to mass, or what is p over here? P1 in this case, what is p or delta p? Delta p, you can very well understand that, like it will be mv. Why? See, the final momentum will be 0. Why? This particular object is coming to rest, so the final momentum will be 0. So what will be the initial momentum? Initial momentum is mv. So what will be the change in momentum? Change in momentum, I'm not putting the sign, like it is mv only. Okay, so first case we have delta p1 is mv. Now in the second case, read. The experiment is repeating with an exact same block. Mass is not changing, but the initial velocity is doubled. Okay, so initial velocity we are doubling. So in the second case, we are using the same mass, but the initial velocity now is 2v. So what will be the initial momentum? Pi will become 2mv. Okay. Now, what is Pf again? Look at exact same force is applied to stop it. You are stopping it. So Pf again in the second case also will be 0. So what is delta P2? Delta P2 will be equal to 2mv because P final. Now what is the relation between P1 and P2? You know that it's double of it. So P2 will be double of P1. Okay. Now, secondly, yeah, we have two options, right? Yeah, these two options are correct. Now, what about the time taken? See, over here the velocity less, you are applying the same force, it will take t1. Then over here the velocity is double, you are applying the same force, which means it will take too much time, more time. Okay, so which one will be? t2 will be double of t1. Okay, so this will be the understanding. Fine. Now, so this is all about the lesson 4. Now we will start with the lesson 5. But before going ahead with lesson 5, in lesson 4, we have one more concept called angular momentum. This angular momentum we will be discussing along with lesson 5. Okay, and it's connected with the rotational moment. Okay.